Hi and welcome to Down the Shed. So in this experiment we shall be doing experiment number 12, one-way light bulbs. Now you might notice it's quite daylight outside. That's because it is. And shortly you might notice it's pitch black outside. That's because it will be. So diodes made of gallium arsenide need a higher voltage across them to turn on, usually about 1.5 volts. This turn on energy is so high that light is generated when current flows through the diode. That will be an LED. Most LEDs are gallium arsenide. These diodes are the light emitting diodes that you've been using, so that's probably the solid colour ones. I don't know about the clear ones, I'm guessing they're the same. To demonstrate this, connect the wires according to the wiring checklist. So let's have a quick look at the schematic. And the wiring diagram. And the wiring checklist. Okay, so 37 to 42. So that'll be the negative or the cathode of the capacitor, 100 UF, to the 3.3 kΩ resistor, as always. 43 to 1. So we are utilising both of the LEDs in this experiment. One will be forward biased and one will be reverse biased. I can't really explain half of what's going on because it's kind of 1 to 4. So we're going from the cathode of 1 to the anode, or the positive, of 4. So negative to positive. 2 to 3. So positive to negative, which if we were doing it in series would be correct. We put a voltage through 1 and 4 and connected 2 and 3, we'd light both LEDs up together. So 43 to 1, 1 to 4, 2 to 3, yep, oh, we've done 2 to 3. We don't want to 4, so we've done 2 to 3, 3 to 26. What a decent length, wasn't it? That'll do. So 3 to 26, so that's the positive of the to the negative, positive of the LED to the negative of the battery. 36 we leave unconnected, which will be the positive of the capacitor. So a quick look in daylight. If we touch the positive of the battery, we will light one LED and then it will dim out as the capacitor discharges. Now if we reconnect that, nothing happens. We touch the negative, we light the other one, and then that dims out. So I'll come back when it's dark and just rerun that part of the experiment. So touch the loose wire to the battery and watch LED 1. It will be bright initially as the current flows to charge up the 100 UF capacitor, and then will dim as the capacitor voltage reaches the battery voltage. So this is charges up, lighting this, the voltage matches that and it dims. LED 2 will not light since it is reverse biased. Touch the loose wire to the negative side of the battery, ground, and watch LED 2. It will be bright initially as current flows to discharge the 100 UF capacitor, and then will dim as the capacitor voltage drops to 0. LED 1 will not light since it is now reverse biased. So we can try different resistor values. So we'll bung this into the 1K, see what happens. We should probably get a brighter LED. like I say, we'll come back in the dark and redo the experiment. So now if we touch 27, that one will brighten up again and dim out. Now this is charged, it's met the same voltage as the battery. We can discharge it by connecting that one up. So I'll leave that there. We'll come back in a couple of hours. When it's dark, I'll rerun the experiment so you get a better idea of the brightness, etc., and just a better view of it working. So I'll see you in a second, or 2 hours for me. If you can hear a little bit of talking in the background, I'm watching Al Jazeera news. So as you can see, it's now dark out, so I'll kill the light and we shall not be moved. I've gone to the 10k resistor from the 3.3. So to start with, we'll touch the positive. You can see a dim LED light up and go out. So we'll go to the negative, and again the capacitor is now discharging. So positive, the capacitor reaches the battery level and the LED goes out. Discharge the capacitor by going to the ground. So we're going from forward bias to reverse bias, from reverse bias to forward bias. So if we go up to the 1k, a significant difference in brightness. So the positive to charge it up and the negative to discharge it. So you can also see it also does it a lot faster now. It's brighter, but it goes out quicker. So back to the original 3.3k. It shall be a bit dimmer than then, but a lot brighter than before. But it will also take a slight longer to go out. So there we go. Charge, discharge, discharge. So that was experiment 12 one-way light bulbs. So thanks for watching. Subscribe to the channel, like the video, and I'll see you in the next one, the electronic switch, where we introduce the transistors. Ta-ra!